Well, hello there. My name is Steve, and we'll call this Wood Truss Construction 101, and I hope it proves to be helpful for some people that would like to build their own wood trusses someday. I've had people ask me in the past why I have two Corvettes, and I tell them because my shop won't hold four. And that's a 99 red FRC that I really love. And down there's a 1991 L98 coupe that I did a lot of work on myself and repainted it. I'd like to buy one or two more, and I want to put them in this shop over here. And I've already got the concrete poured and the math work done that will allow me to get at least 4 Corvettes in there. And if not, then I'll have some place to store snow plows and things like that for the winter time. So I'm going to build an addition onto this shop, and I've decided to do it with wood trusses. So I need to match up a 312 pitch roof up there, and that's not a common truss size for sure. Well, the reasons I'm building my own roof trusses is that I only need 7 of them to start with, and they're a custom size. It's a 312 pitch with a 26 foot 6 1/4 inch bottom chord dimension. So you can't go to the local lumberyard or Menards or any place like that and just order these without doing a custom fabrication, and that's going to cost quite a bit of money. This truss would be in the $75 range if I had to buy it ready built, and then the delivery fees would add to that. I'm able to buy the lumber to do this for about 25 bucks, and some glue, some nails, some plywood for the gussets. But the first thing you need to do is do a good accurate layout, probably on a nice somewhat level and in plane surface, and I've done that. And when I got done, I locked it down with some clear lacquer that's still drying so that I don't lose these dimensions and marks and all the work that I've done. The blue and the black are actually the 3.5 inch 2x4 dimension width, and the orange lines you see are the plywood gussets that are going to lock these in place. When I'm all said and done with this, I think I came up with a total of 11 truss parts, which is bottom cord, top cord, and connecting web members. And then I came up with 9 gusset plates on each side, so I've got a total of 18 gusset plates. And probably the biggest reason I'm doing this is because even to do a custom order of this truss, it would take 6 to 8 weeks to get it. And weather's running out, so I'm going to go ahead and fab them up myself. Well, I took my iPhone and asked Siri what the angle of a 312 pitch was, and she told me 14.04 degrees, so I have my miter gauge set up 14.4, and I got a stop block on the table saw. So with this device I'll be able to make my gusset plates for the ends of the truss. We're cutting the top gussets now. We'll go right there. Looks like it ought to work. Well, for the past probably 3 or 4 hours or so, I've been using the table saw mostly to cut gusset plates. And I could take my miter gauge and set it on 14 degrees, which is what it's set at, which is the angle common for the 312 pitch truss. And so I've got a lot of gusset plates cut and stacked up over here. And here's, let's see, 1, 2, 3, 4, 5, 6 different varieties of plates, I guess. There's a lot of pieces. Each truss will get 9 gusset plates each side, so a total of 18 gusset plates. And I'll start off down here on the end where you can see that one will go there. and then this one will connect a vertical member to a horizontal bottom cord, and that piece there will connect the top cord and the web compression member and the vertical member. Over here we've got one that will connect several pieces in the middle of the truss down at the bottom, and then the one up at the top, and then this long piece here, it's 4 feet long, it'll connect a splice in the bottom cord, and then the same thing that we had down on the other end. The actual truss pieces themselves are about 9 pieces. There's 2 pieces of bottom cord, 2 pieces of top cord, this member right here, and 2 of these that connect down here, and the 1 vertical post. So anyway, we're about to the place now where we're ready to start cutting actual truss structural members, and then we'll nail one together. All the parts for the first truss cut and assembled, and we're ready to glue it up and nail it up. And I guess there's actually a total of 11 parts. I forgot about these little filler blocks on each end. And for all the parts that I've made patterns as well. So that one corresponds to that one, and that one corresponds to that one. And the top cord, I've got a plumb cut on each end, so that's the pattern laying there, and then the king post in the middle for that piece. So I can easily duplicate them from here on out. One thing that works good to kind of start the assembly process is to use this stapler, a do-fast stapler with a 9/16 staple in it, and then you can just tack the pieces together loosely. And from there on out, it's just a process of taking the urethane construction adhesive and gluing up the gussets and nailing them in place. Ready to nail up this first truss. And one last check before I did it, and like any good carpenter does, or hope they do anyway, you get your eyeball down there and you line up the bottom cord, and you can sight right down it, and then you can sight up the top cord as well. And I saw a bow in the bottom cord that I didn't like, and so one thing that you can do to really force you to be consistent and to keep things straight is to attach some stop blocks or locating blocks. So I've done that. There's one right there, another one right there. At every point that the top and bottom cord are connected, I've taken and put a locating block on the original chalk line layout. And as long as I'm building within those stop blocks and keeping the web members reasonably tight, I should maintain consistency, and I should build a straight truss. Nail up the gussets now. And it'd probably be a good idea if you'd use some premium urethane based construction adhesive. This stuff's really, really good. And basically, you're doing something like that. And then taking the gusset and putting probably the best side of the gusset down and wiggling it around a little bit, get it bedded in the glue, and then nail it down. And basically all the nails are doing is holding the thing in place while the glue cures. Once it's done curing, the glue is probably going to take the bulk of the load. Take the best side of the gusset plate and put it in the glue. Move it around a little bit. Get that glue bedded in well. Make sure the gusset plate doesn't overhang the bottom cord. And that's how you do gusset plates. Finished up assembling these 7 trusses. They're a custom size. They would have cost me probably $75 a piece to have them fabricated, plus delivery charges. So figure 80 times 7, somewhere 550 bucks or so. Did I do the math right? Anyway, I built them for about 25 bucks a piece. If I had it to do over again, I probably wouldn't do it if I had the time to order them and had a little bit extra money. As it is, I probably saved about $300 doing this myself. But if you value your time, probably not a wise choice to build them yourself. But quality-wise, they're every bit as good. They're maybe a little bit heavier than a normal truss with a plywood on. It's probably about a half a sheet of plywood on each truss, so they're a little heavy, but they'll do the job.